Hi, we continue section 4b, the off payments part 2. So we introduce a new notation. So A right angle n superscript m I. So this is the present value of the following cash flow. So basically this m means the m payments per year. So we have the time diagram. Basically, this is n-year annuity, but the payment is 1 over m year. So if m is equal to 4, that is quarterly payments. M is equal to 12, then monthly payments. So 1 over m, 2 over m, up to 1. Then next one is 1 plus 1 over m, and the 1 plus 2 over m, up to 2, and so on. Then finally, we have n. And the payment amount is 1 over m dollar per 1 over m year. And that's the same amount for every 1 over m years. So notion is that we have $1 payment per year. So if we consider the total payment during 1 year, that is $1. And this A right angle n superscript m is the present value of this annuity. So present value here, the A right angle n superscript mi, and this is I's annual effective interest rate. This is annual rate. And this is the definition of A right angle n superscript m. So the point is that the total payment is n dollars. So this is basically a version of A right angle n. So in total, $1 payment per year. So total payment is not mn dollars. So total number of payments is m times n, but the total payment amount is n dollars. So present value is slightly less than n. Yeah, and this one, the A right angle n superscript m. So this is the present value of 1 per annum payable in M3 installments for n years that we say. So 1 per annum just means the $1 per year, and payable in M3. M3 is a strange word, but that means quarterly if m is equal to 4, or monthly if m is equal to 12, and the daily if m is equal to 365. So we can say in words that $1 per annum payable in M3 installments for n years. Okay, so this is the definition. And now that we want to develop the formula to calculate this A right angle n superscript m. So basically, this is similar amount to A right angle n. Can you imagine which is larger, A right angle n or A right angle n superscript m? Approximately the same, right? But actually, A right angle n superscript m is slightly larger because you can see that the sum payments are earlier than usual, the annuity immediate. For annuity immediate, $1 is paid at time 1 for the first time. But the M3 payment, the sum partial amount is paid earlier. So that means the slightly larger than the present value is slightly larger than usual annuity immediate. Okay, so the theorem. So A right angle n superscript m I. This is the I over I superscript m. So this is basically annual rate the nominal annual rate, but which is equivalent to the effective rate of I. And remember that I superscript m is slightly smaller than I. So basically, these two quantities are similar. So I and I superscript m are similar quantity that we express the same interest in a slightly different way. I superscript m is slightly smaller because it compounds m times. So, or we can say that the a right angle n is 1 minus Vn over I. So if you cancel the I, this is 1 minus V to the nth power over I superscript m. Yeah. Okay, so just the review of I superscript m. So recall that the I superscript m is equal to m times 1 plus I to the power 1 over m minus 1. Or equivalently, the 1 plus, 1 plus I superscript m over m to the m's power is equal to 1 plus I. So both I are the same rate, but the I superscript m, the compounds m times a year. But still, this is a nominal rate. So nominal rate, so we divide it by m, and to the m's power, then that becomes 1 plus I. So 1 I superscript m is the interest for 1 over m year. But the still, this is expressed as annual rate. Yeah, so for example, remember that the definition. For example, if I is equal to 3%, 0.03, then I superscript m is equal to the 12 times 1.03 to the 12th power minus 1, and this becomes the 0.0296. Yeah. Actually, the credit union I'm using that says that the annual effective interest is 3%, but if you deposit the $10,000, it earns almost $300 in interest for every month. Sorry, it says that almost the interest rate for the month is the 1/12 of this, the 2.96%. So that means the I superscript 12 is equal to the 2.96%. Okay, so we finished the review, and now we want to prove this formula. So a right angle n superscript m is equal to this quantity. Yeah, so we think about the time diagram again, and we use the similar idea. We use the similar idea as some previous examples in this section. So our time unit is a year, but the payment is more frequent, so that is a problem. So we consider annual payment, which is equivalent to this m payments per year. So this is the time diagram, and we consider the payment of R per year, which have the same present value as m payments of 1 over m dollars. So we equate the present values of these two payments. Yeah, and we want to determine R. Then we can actually calculate the present value of this. So let R, so in sentence, let R be the accumulated value of at time 1 of M payments per year. I mean, M payments per year of the $1 M, 1 over M dollar each. Then, what is R? So we can use the accumulated, so annuity immediate formula to calculate R. So R is actually 1 over M times the S right angle M, because this is M payments of 1 over M dollars at interest rate J, and J is the effective rate for 1 over M year. So J is the effective rate, effective interest rate for 1 over M year. So that means the J is equal to 1 plus I to the power 1 over M minus 1. So we can say that by this definition of I superscript M, that we can say that the MJ is equal to I superscript M, right? So if you multiply M on both sides, then the both becomes this. So MJ is equal to I superscript M. So R is this quantity. So this equals to, so 1 plus I to the power M minus 1 over I. Sorry, the 1 plus J. So we are thinking about the time unit as 1 over M year. So R is equal to 1 over M times S right angle MJ times this, and over J. But we have 1 over M here, so M times J. So you can see that the S right angle M formula is here. So times M. Yeah. So we use the time unit of 1 over M years. Then what is this? 1 plus J to the power M is equal to 1 plus I. And minus 1 over I superscript M. Okay. So this comes from here. So MJ is this, so MJ is equal to this. So this becomes actually the I over I superscript M. So now that we got the close to the theorem. So again, that we used 1 over M year as time unit. Okay, so now we have determined R. So we can now calculate the entire quantity. So going back this, so we equate this M payments as R, right? And the M payments as R, and so on. So now that we have just N payments of R, and R is equal to I over I superscript M. So that means that this quantity A right angle N superscript M is annuity immediate of R for N years. So present value of this annuity is equal to R times A right angle N at I. So n payments of R. And R was obtained in the previous line. R is equal to I over I superscript M. So that means I over I superscript M times A right angle Ni. So we have already got the answer. We have already got the proof. Or if we cancel this I by writing down the formula for area right angle N. So this becomes 1 minus Vn over I superscript M. So this is the end of the proof. So now that we proved that the A right angle N superscript M is equal to this quantity, or we can say this quantity. And I superscript M is slightly smaller than I. So that means A right angle N superscript M is slightly larger than A right angle N if interest rate is the same.